Welcome to this video session. The topic that we are going to cover in this session is bonding in carbon and its versatility. So friends, before we move ahead with our discussion, we should know that the atomic number of carbon is 6, which means that a neutral atom of carbon contains 6 electrons. How will the distribution of electrons in different orbitals of carbon occur? But friends, why are we studying about the electronic configuration? We are studying its electronic configuration so that we can understand the type of bonding in carbon. Carbon has 4 electrons in its outermost shell. So it should either lose 4 electrons or gain 4 electrons to achieve noble gas configuration. But really, is it possible? As carbon is a small atom, so outermost electrons are held strongly by the nucleus of the atom. So, it is not possible to remove 4 electrons from carbon. Also, it is not possible to gain these many electrons due to energy considerations. Let's assume if it were to gain or lose electrons. 1. It could gain 4 electrons forming C4- anion. But it would be difficult for the nucleus with 6 protons to hold on to 10 electrons. That is 4 extra electrons. Second, it could lose 4 electrons forming C4+ cation. But it would require a large amount of energy to remove 4 electrons, leaving behind a carbon cation with 6 protons in its nucleus, holding on to just 2 electrons. Carbon overcomes this problem by sharing its valence electrons with other atoms of carbon or with atoms of other elements. Carbon atom has 4 electrons in its outermost shell, so it requires 4 more electrons to achieve the noble gas configuration, which it gets by sharing electrons. Since one carbon atom requires 4 electrons to achieve the nearest noble gas configuration, therefore, it has a valency of 4, that is, carbon is tetravalent. Not just carbon, but many other elements form molecules by sharing electrons in this manner. The shared electrons belong to the outermost shells of both the atoms and lead to both atoms attaining the noble gas configuration. Before going on to compounds of carbon, let us look at some simple molecules formed by the sharing of valence electrons. The simplest molecule formed in this manner is that of hydrogen. As we have previously studied, the atomic number of hydrogen is 1. Hence, hydrogen has 1 electron in its K shell and it requires 1 more electron to fill the K shell. So, 2 hydrogen atoms share their electrons to form a molecule of hydrogen, H2. This allows each hydrogen atom to attain the electronic configuration of the nearest noble gas, helium, which has 2 electrons in its K shell. Such bonds, which are formed by the sharing of an electron pair between 2 atoms, are known as covalent bonds. Covalently bonded molecules are seen to have strong bonds within the molecule, but intermolecular forces are weak. This gives rise to the low melting and boiling points of these compounds. Since the electrons are shared between atoms and no charged particles are formed, such covalent compounds are generally poor conductors of electricity. Let us now discuss about the versatile nature of carbon. We have seen the formation of covalent bonds by the sharing of electrons in various elements and compounds. We also know the structure of a simple carbon compound, methane. We also know about how many things we use contain carbon. In fact, we ourselves are made up of carbon compounds. The nature of the covalent bond enables carbon to form a large number of compounds. Two factors noticed in the case of carbon are: 1. Carbon has the unique ability to form bonds with other atoms of carbon, giving rise to large molecules. This property is called catenation. These compounds may have long chains of carbon, branched chains of carbon, or even carbon atoms arranged in rings. In addition, carbon atoms may be linked by single, double, or triple bonds. Compounds of carbon which are linked by only single bonds between the carbon atoms are called saturated compounds. Compounds of carbon having double or triple bonds between their carbon atoms are called unsaturated compounds. This gives us the large number of compounds with many carbon atoms linked to each other. 2. Since carbon has a valency of 4, it is capable of bonding with 4 other atoms of carbon or atoms of some other monovalent element. Compounds of carbon are formed with oxygen, hydrogen, nitrogen, sulfur, chlorine, and many other elements, giving rise to compounds with specific properties which depend on the elements other than carbon present in the molecule. The two characteristic features seen in carbon, that is, tetravalency and catenation, put together give rise to a large number of compounds. Many have the same non-carbon atom or group of atoms attached to different carbon chains. These compounds were initially extracted from natural substances, and it was thought that these carbon compounds or organic compounds could only be formed within a living system. Friends, in this video, we studied about bonding in carbon and its versatility. In the next video, we will learn about saturated and unsaturated carbon compounds. Welcome to this video session. The topic that we are going to cover in this session is saturated and unsaturated carbon compounds. So children, before we move ahead with our discussion, we should know that a compound made up of hydrogen and carbon only is called hydrocarbon, and these hydrocarbons are of two types, which are saturated and unsaturated hydrocarbons. Children, first of all, we will discuss about saturated hydrocarbons, and they are also called as alkanes. A hydrocarbon in which carbon atoms are connected only by single bond are called as saturated hydrocarbon. It is also called alkane. Thus, the hydrocarbons methane, ethane, propane and butane are alkanes. The names of all these saturated hydrocarbons end with ane. The general formula of saturated hydrocarbons or alkanes is CnH2n plus 2, where N is the number of carbon atoms. Let's discuss saturated hydrocarbons with the help of examples. 1. If an alkane has one carbon atom in its molecule, when N equal to 1, and its molecular formula according to the general formula becomes CH4, which we call methane. 2. Similarly, if we take N equal to 2, we get ethane. These saturated hydrocarbons are normally not very reactive. That is, they are quite unreactive. A hydrocarbon in which the two carbon atoms are connected by a double bond or a triple bond is called an unsaturated hydrocarbon. Ethene and ethine are two important hydrocarbons because ethene contains double bond and ethine forms a triple bond. A double bond is formed by sharing two pairs of electrons between the two carbon atoms, whereas a triple bond is formed by the sharing of three pairs of electrons between two carbon atoms. The unsaturated hydrocarbons are obtained mostly from petroleum by the process called cracking. Unsaturated hydrocarbons are of two types. 1. Double bonded hydrocarbons, also called alkenes. 2. Triple bonded hydrocarbons, also called alkynes. We will now discuss each in detail. An unsaturated hydrocarbon in which the two carbon atoms are connected by a double bond is called an alkene. So, these alkenes contain a double bond between two carbon atoms which is formed by the sharing of two pairs of electrons. Ethene C2H4 and propene C3H6 are the two alkenes. Why? Because they contain double bond between the two carbon atoms. There is also an interesting fact. Do you know, children, that there can be no alkene having only one carbon atom? The general formula of an alkene is CnH2n, where N is the number of carbon atoms in its molecule. Let's take an example. 1. If an alkene has two carbon atoms in its molecule, then N is equal to 2 and its molecular formula will be C2H4. 2. Similarly, when N is equal to 3, we will get propene. The simplest alkene is ethene and its common name is ethylene. Let us now discuss about the alkynes. These are unsaturated hydrocarbons in which the two carbon atoms are connected by triple bonds. So, the alkynes contain a triple bond between carbon atoms which is formed by the sharing of three pairs of electrons. Ethyne and propyne are alkynes because they contain a triple bond between two carbon atoms. Also, another amazing fact is that there can be no alkyne having only one carbon atom. The general formula of alkynes is CnH2n-2, where N is the number of carbon atoms in one molecule of alkyne. Let us discuss this with the help of examples. 1. If an alkyne has two carbon atoms in its molecule, then N is equal to 2 its formula will be C2H2, which is ethyne. 2. Similarly, if we take N equal to 3, we will get propyne. The simplest alkyne is ethyne. With formula C2H2, its common name is acetylene. Also children, you should know that the unsaturated hydrocarbons are more reactive as compared to saturated hydrocarbons. In other words, alkenes and alkynes are more reactive than alkanes. The alkane having 2 carbons is called ethane. The alkene having 2 carbons is called ethene. And the alkyne having 2 carbon atoms is ethyne. All these compounds are covalent molecules which are formed by the sharing of electrons between various atoms. Friends, welcome to this video. Today we will study about homologous series and nomenclature of carbon compounds in this video. Suppose we divided many books according to their subject. That is, all the books of Hindi, English, Science, etc. were kept separately. As its name suggests, homologous carbon compounds can be defined as a group of similar type of carbon compounds that have the same general formula and functional group. The alkane hydrocarbon series are as follows: methane, ethane, propane, butane, pentane, etc. In moving from one unit to another unit, there is a difference of CH2 unit. For example, there is a difference of CH2 unit from methane to ethane. There is also a difference of CH2 from ethane to propane, propane to butane, butane to pentane. And as you can see, we can represent any compound of this category by CnH2n plus 2 by this formula. For example, in the first compound of the series methane, N will be 1. Now, if we write 1 instead of N in this formula, we will get molecular formula of methane CH4. All carbon compounds in this category belong to a single bond, and so N will be added at the end of the name, such as methane, ethane, etc. It also means that there is a difference of 14 mass between one unit to another unit. Because the mass of CH2 is 14, as the mass increases in the homologous series, the mass of the molecule will increase. If the hydrocarbon compound contains carbon-carbon double bond, then that category will be called alkene. That is, ene will be added at the end of the name. For example, ethylene, propene, butene, pentene, etc. In this series too, there is a difference of CH2 unit in moving from one unit to another. And as you can see, we can show CnH2n, any compound of this category, by this formula. For example, in the second compound, ethene, the N will be 2. Now, If we write 2 instead of N in this formula, we will find the molecular formula C2H4 of ethene. Similarly, if the hydrocarbon compound contains carbon-carbon triple bond, the series will be called alkyne. The name will end with -ine, and the same important thing is that there will be a difference of CH2 unit in moving from one unit to another. And we can show any compound in this carbon series by this formula, CnH2n -2. Let us now understand that what functional group is called, such as OH, alcohol, Cl, chlorine, Br, bromine, etc. This functional group gives compounds special characteristics. When another group displaces a hydrogen inside a hydrocarbon, it is called a functional group. For example, take alcohol, OH. If an OH alcohol group is added instead of a hydrogen of methane hydrocarbon, the name OL will be added to form methanol. Similarly, the entire homologous series is composed methanol, ethanol, propanol, butanol, pentanol, etc. You must have understood by now that this is a homologous category of alcohol, and here too, CH2 has to be added to move from one unit to the next. And moving from one unit to the next unit changes 14 mass. And because they all have the same functional group OH, they all have similar chemical properties. Similarly, you can form homologous categories by placing different functional groups in hydrocarbon groups. So now you must have understood a series of compounds in which the same functional group substitutes for hydrogen in a carbon chain is called a homologous series. The most important formula for this is that it takes one CH2 and 14 masses to move from one unit to another. When molecular mass increases in a homologous series, there is a gradation in physical properties. This is because the melting point and boiling point increase as the molecular mass increases. The chemical properties that are ensured by a purely functional group remain the same in the homologous series. Hope you will not have any dilemma related to homologous series. Let us now study the method of naming carbon compounds. Before understanding the nomenclature of carbon compounds, we will see an example of a name, like Mr. Mahendra Singh Dhoni. In this name, Mr. can be called prefix. Mahendra is the first name, Singh is the middle name, and Dhoni is surname. Similarly, the name of carbon compounds is also divided into 5 parts. Let us know what those 5 parts are. The first part is the primary prefix. Then comes the second prefix. Then comes the carbon chain. Then comes the second attachment which joins behind the name. And then comes the primary attachment. In this way, the name of our carbon compound is divided into 5 parts. Now, we will discuss the rules of this nomenclature. But it can be a bit difficult for you to understand at once because, like mathematics, you will need to practice it. By discussing it through examples, it will start easy to understand and you will be able to name any compound. Let's know about the nomenclature. See, first you have to tell about the substitution. Now, what is this replacement? Just like there are only carbon and hydrogen, it is called hydrocarbon. If inside it we remove any hydrogen and replace it with fluorine, because both hydrogen and fluorine form a bond with carbon. Similarly, chlorine, bromine or iodine can replace hydrogen. What is this now? These are substitutions. Because they have replaced hydrogen by replacing it, in English it is called substitution. So far we have discussed 4 substitutions. You will learn about more substitutions later. What to write if fluorine is added in carbon compounds? Write fluoro before the name, and if chlorine is added, chloro. If bromine is added, we will write bromo. And if iodine is added, then we will write iodo. So what is the first thing to look for in an organic compound? Will you see fluorine, chlorine, bromine or iodine? So we can write the primary prefix accordingly. After this, will you see which type of ring is being formed in carbon? You can easily see this. That is, the chain of carbon is straight or forming a ring. If the ring is formed, then you will use the word cyclo. Then you will come to the main carbon chain. How many carbons are there? If there is 1 carbon, then we will write meth. If there are 2 carbons, then we will write eth. If there are 3 carbons, then we will write prop. If there are 4 carbons, we will write bute. If there are 5 carbons, then we will write pent. If there are 6 carbons, then we will write hex. If there are 7 carbons, then we will write hapt. If there are 8 carbons, then we will write oct. If there are 9 carbons, then we will write non. If 10 carbons, then we will write dec. You must remember this sequence very well. Now you can see whether the carbon is having single bond or double bond in the compound or triple bond. If there is a single bond, you will write ene. If there is a double bond, you will write ene. And if there is a triple bond, you will write eine. Now we can check the primary attachments are functional groups. They are as important as surname in carbon name. If OH or hydroxyl is seen in the primary, it is alcohol. For this, you will write OL. If you see CHO, that is aldehyde, you will write al for it. If you see COOH, this is carboxylic acid. For this, we will say OIC, oic acid. If you see CO, this is ketone, and you will write one for it. These are the magical formulae that once you have understood, you can write the name of any carbon compound. We will study the chemical reactions of carbon compounds in the next video. Welcome to this video session. The topic that we are going to cover in this session is chemical properties of carbon compounds. Friends, the most common carbon compounds are hydrocarbons, which are alkanes, alkenes, and alkynes. The chemical properties which we are going to study here are combustion reactions, oxidation reactions, addition reactions, and substitution reactions. Combustion reaction occurs in all types of hydrocarbons. Substitution occurs only in saturated hydrocarbons, whereas addition reactions are given by only unsaturated hydrocarbons, alkene and alkynes. Let us start with combustion reactions. Carbon, in all its allotropic forms, burns in oxygen to give carbon dioxide along with the release of heat and light. Most carbon compounds also release a large amount of heat and light on burning. These are the oxidation reactions. Saturated hydrocarbons will generally give a clean flame, while unsaturated carbon compounds will give a yellow flame with lots of black smoke. However, limiting the supply of air results in incomplete combustion of even saturated hydrocarbons, giving a sooty flame. The gas or kerosene stove used at home has inlets for air so that a sufficiently oxygen-rich mixture is burnt to give a clean blue flame. If you observe the bottoms of cooking vessels getting blackened, it means that the air holes are blocked and fuel is getting wasted. Fuels such as coal and petroleum have some amount of nitrogen and sulfur in them. Their combustion results in the formation of oxides of sulfur and nitrogen, which are major pollutants in the environment. So, friends, how can we define combustion reaction? The process of burning of a carbon compound in air to give carbon dioxide, water, heat, and light is called combustion. Let us discuss one more example. Alkanes burn in air to produce a lot of heat, due to which alkanes are excellent fuels. The process in which a compound gains oxygen or loses hydrogen is called oxidation reaction. Carbon compounds can be easily oxidized on combustion. In addition to this complete oxidation, we have reactions in which alcohols are converted to carboxylic acids. We see that some substances are capable of adding oxygen to others. These substances are known as oxidizing agents. Alkaline potassium permanganate or acidified potassium dichromate are oxidizing alcohols to acids, that is, adding oxygen to the starting material. Hence, they are known as oxidizing agents. So, now we know what is oxidation and what are oxidizing agents. Let's move towards the next type of reactions. In the presence of sunlight, chlorine is added to hydrocarbons in a very fast reaction. Chlorine can replace the hydrogen atoms one by one. It is called a substitution reaction because one type of atom or a group of atoms takes the place of another. Saturated hydrocarbons are quite unreactive and do not react with many substances, but they undergo substitution with chlorine in presence of sunlight. Also, since this substitution is taking place by chlorine, it is called chlorination. Chlorine can replace the hydrogen atoms one by one. It is called a substitution reaction because one type of atom or a group of atoms takes the place of another. A number of products are usually formed with the higher homologues of alkanes. In this given reaction, only one hydrogen atom of methane has been replaced by chlorine atom and we get chloromethane. By supplying more chlorine, it is possible to replace all the hydrogen atoms of methane by chlorine one by one. In this way, we can obtain 3 more compounds: dichloromethane or methylene dichloride, trichloromethane and tetrachloromethane. Let's move towards the next type of reactions. The reaction in which an unsaturated hydrocarbon combines with another substance to give a single product is called addition reaction. Addition reactions like addition of hydrogen, chlorine or bromine are a characteristic property of unsaturated hydrocarbons. Addition reactions are given by all unsaturated hydrocarbons having double or triple bonds, that is, alkenes and alkynes respectively. Unsaturated hydrocarbons add hydrogen in the presence of catalysts such as nickel or palladium. Catalysts are those substances that cause a reaction to occur or proceed at a different rate without the reaction itself being affected. This reaction is commonly used in hydrogenation of vegetable oils using nickel catalysts. Vegetable oils generally have long unsaturated carbon chains, while animal fats have saturated carbon chains. You may have noticed that some advertisements say that vegetable oils are healthy. Generally, animal fats contain saturated fatty acids, which are considered harmful to health. Oils containing unsaturated fatty acids should be chosen for cooking. In general, unsaturated hydrocarbon add on hydrogen in the presence of a catalyst such as nickel or palladium to form saturated hydrocarbons. The addition of hydrogen to an unsaturated hydrocarbon is called hydrogenation, and this hydrogenation is process used to prepare vegetable ghee from vegetable oils. Friends, in this video, we have studied the chemical properties of carbon compounds. In the next video, we will learn about ethanol and ethanoic acid. Welcome to this video session. The topic that we are going to cover in this session is ethanol and ethanoic acid. Many carbon compounds are invaluable to us, but here we shall study the properties of 2 commercially important compounds, ethanol and ethanoic acid. Ethanol is a liquid at room temperature. It is commonly called alcohol and is the active ingredient of all alcoholic drinks. In addition, because it is a good solvent, it is also used in medicines such as tincture iodine, cough syrups, and many tonics. Ethanol is also soluble in water in all proportions. Consumption of small quantities of dilute ethanol causes drunkenness. Even though this practice is condemned, it is a socially widespread practice. However, intake of even a small quantity of pure ethanol, called absolute alcohol, can be lethal. Also, long-term consumption of alcohol leads to many health problems. We will now discuss the reactions of ethanol. 1. Reaction with sodium, Na. Alcohols react with sodium, leading to the evolution of hydrogen. With ethanol, the other product is sodium ethoxide. 2. Reaction to give unsaturated hydrocarbon. Heating ethanol at 443 K with excess concentrated sulfuric acid results in the dehydration of ethanol to give ethene. The concentrated sulfuric acid can be regarded as a dehydrating agent which removes water from ethanol. Ethanoic acid is commonly called acetic acid and belongs to a group of acids called carboxylic acids. 5 to 8% solution of acetic acid in water is called vinegar and is used widely as a preservative in pickles. The melting point of pure ethanoic acid is 290 K and hence it often freezes during winter in cold climates. This gives rise to its name, glacial acetic acid. The group of organic compounds called carboxylic acids are obviously characterized by their acidic nature. However, unlike mineral acids like HCl, which are completely ionized, carboxylic acids are weak acids. Now, we will discuss the chemical reactions of ethanoic acid. 1. Esterification. Esters are most commonly formed by reaction of an acid and an alcohol. Ethanoic acid reacts with absolute ethanol in the presence of an acid catalyst to give an ester. Generally, esters are sweet-smelling substances. These are used in making perfumes and as flavoring agents. On treating with sodium hydroxide, which is an alkali, the ester is converted back to alcohol and sodium salt of carboxylic acid. This reaction is known as saponification because it is used in the preparation of soap. Soaps are sodium or potassium salts of long-chain carboxylic acid. 2. Reaction with base. Like mineral acids, ethanoic acid reacts with a base such as sodium hydroxide to give a salt, sodium ethanoate, or commonly called sodium acetate, and water. 3. Reaction with carbonates and hydrogen carbonates. Ethanoic acid reacts with carbonates and hydrogen carbonates to give rise to a salt, carbon dioxide, and water. The salt produced is commonly called sodium acetate. This was all about the physical and chemical properties of ethanoic acid and ethanol. Friends, in this video,